Have you ever just stopped and thought about the stuff that makes up, well, literally everything around us? From the air you're breathing to the phone in your hand, we're surrounded by this incredible hidden world of mixtures. And today, we're going to dive right into the surprising science behind it all. So let me ask you something right off the bat. Go ahead, take a deep breath. Now, that air that's filling your lungs, would you say that's one single pure thing? Yeah, the answer is no, not even close, actually. The air we breathe is this surprisingly complex cocktail of different gases, dust, and even tiny droplets of water. And really, that's the big idea for today. Most of the stuff we run into in our daily lives isn't pure at all. It's a blend of different things. So let's get into it. Let's explore this hidden world of mixtures. Okay, so the first thing you've got to know is that not all mixtures are made the same. You can kind of think of them as having two totally different personalities. I like to call them the chunky salad and the perfect smoothie. Let's start with the chunky salad. Now, in science speak, this is a heterogeneous mixture. And the main thing to remember here is that you can easily see all the different bits and pieces because they just aren't mixed together evenly. Just think about it, right? Sand swirling around in water, a bowl of uncooked rice and lentils, or even just oil floating on top of water. You can see every single separate component, can't you? Well, that's a heterogeneous mixture. And then you've got the perfect smoothie. This is what we call a homogeneous mixture. In this case, everything is blended so perfectly, so uniformly, that the whole thing just looks like one single substance. Remember that air we were talking about a minute ago? Yep, that's a homogeneous mixture. Same goes for salt dissolved in water. I mean, once you stir it in and it disappears, you can't see the little salt crystals anymore, right? The whole thing just looks like water. And here is a super simple way to see this in action. If you try to mix oil and water, what happens? They refuse to mix. You get those two distinct layers you can clearly see. That's heterogeneous. But if you mix alcohol and water, they blend together perfectly. You can't tell where one ends and the other begins. That's homogeneous. Simple as that. Okay, so we get the two types of mixtures, but now let's talk about taking them apart. I mean, why would we ever actually need to unmix things? Well, the reasons are pretty much all around us. We separate mixtures to get something we really want, like getting salt from the ocean. Or we do it to remove something we don't want, like picking little stones out of a bag of rice. And sometimes we need something to be incredibly pure, like distilled water that's used in medicines. So how do we actually do it? Well, the secret is surprisingly simple. Every single part of a mixture has its own unique properties, like its size or its weight, or maybe if it's magnetic. The whole game of separation is just finding those differences and using them to pull everything apart. So now let's open up the scientist's toolkit and take a look at a few of these really clever tricks for separation. First up, you've got magnetic separation. This one's pretty straightforward. If you have a mixture and one part of it is magnetic, say you've got iron filings mixed in with some sulfur powder, all you have to do is bring a magnet close and poof, the iron filings jump right out. Super simple, but incredibly effective. Next is a technique I bet you've already used today. Filtration. Seriously, just think about making a cup of tea. That strainer you use, that's a filter. It lets all the liquid tea flow right through, but it catches and holds back the solid tea leaves. You just separated a solid from a liquid. And our third tool is evaporation. This one's perfect for those homogeneous mixtures, like our saltwater example. All you do is heat up the solution. The liquid water gets hot, turns into a gas, vapor, and just floats away. And what's left behind? Pure, solid salt crystals. This is exactly how we get salt from the sea, just on a massive, massive scale. So we have seen how to take mixtures apart, but what about putting them together? Let's flip this around and see how creating the perfect blend can lead to some absolutely incredible innovations. And to do that, we have to talk about a very special kind of homogeneous mixture called an alloy. Basically, it's what you get when you melt and mix two or more metals together to create a brand new solid material. And this is where it gets really cool. The new alloy often has properties that are completely different and way better than the individual metals you started with. Now, you're already familiar with some alloys, for sure, things like brass, bronze, and steel. But the world of alloys goes way beyond what we see every day. Some of them are quite literally out of this world. I want you to meet Duralumin.
This is the kind of stuff that spacecraft are made of. See, on its own, aluminum is really, really light, but honestly, it's not very strong, not strong enough for space travel. But by creating this perfect homogeneous mixture, by adding in just small amounts of copper, manganese, and magnesium, engineers created an alloy that is both incredibly light and incredibly strong. It's the best of both worlds, all because of the mix.
So, from the air we're breathing right now to the salads we eat for lunch, we're just swimming in a world of mixtures. Sometimes we need to pull them apart. And sometimes, like with duralumin, the real magic happens in the mix itself. So it makes you wonder, right? If mixing a few metals together can literally get us to space, what other hidden mixtures are out there, just waiting to shape our future?